So we will combine equation 1 and equation 3 to finally solve for FU, FV and FW. So how do we combine the equation 1 and equation 3? By using Lagrange undetermined multiplier. Okay. So we will combine equation 1 and 3 using undetermined multiplier of Lagrange. That is, we will multiply equation 3 by some unknown quantity and add it to equation 1. So suppose we have taken alpha as undetermined multiplier of Lagrange. It's an unknown quantity. Now we multiply equation 3 by alpha. So we will have alpha u du plus alpha v dv plus alpha w dw equals to 0. Now we add this equation to equation 1. So finally, equation 1 plus alpha into equation 3. By doing this, we get f prime u by fu plus alpha u. We are taking the coefficients of du together, then we will take the coefficients of dv together. So we will have f prime v by fv plus alpha v dv. Then we will take the coefficients of dw together, then we will have f prime w by fw plus alpha w dw equals to 0. So this is our equation 4. Now suppose we have chosen alpha in such a way that, so alpha is chosen in such a way that the coefficient of du is 0. So coefficient of du which is f prime u by fu plus alpha u equals to 0. Okay. Therefore, if this is 0, so equation 4 takes the following form: f prime v by fv plus alpha v dv plus f prime w by fw plus alpha w dw equals to 0. This is suppose equation 5. Now if you look at equation 3, from this equation we can say that du, dv and dw are not mutually independent. So if they were independent, these variables du, dv, dw, if they were independent, then if they were independent, then they will satisfy this equation when the coefficients of du, dv, dw will be equals to 0. That is, u, v, w were equals to 0. Okay. So if du, dv, dw were mutually independent, then they will satisfy this equation only when, UVW equals to 0. That is the coefficients of du, that is u, coefficients of dv, that is v, and coefficient of dw, that is w, are separately 0. U equals to 0, v equals to 0, w equals to 0. But it is clear that you can find other values of UVW, other non-zero values of UVW, for which this equation will be 0. This equation will satisfy. Okay, so you can find other non-zero values of UVW, for which equation 3 will satisfy. Therefore, we can say that the variables du, dv and dw are not mutually independent. Okay, but out of these three variables, we can choose any two variables as constant and independent. That is, these three together are not mutually independent, but any two of them can be independent, and we also choose them to be some constants. Okay, so suppose we have chosen dv and dw to be, dv and dw are mutually independent and are constants. Okay, so du, dv, dw, all three together are not mutually independent, but out of these three, these two variables dv and dw are mutually independent, and suppose they are constants. Therefore, this as dv and dw are mutually independent, therefore this equation will satisfy only when the coefficients of dv and dw are separately, individually 0. That is, coefficients of dv, that is this quantity, equals to 0, and also this quantity is equals to 0, because dv and dw are chosen to be mutually independent. Okay, so as we have chosen dv and dw mutually independent, therefore from equation 5, so from equation 5 we have the coefficients of the coefficient of dv, which is f prime v by fv plus alpha v equals to 0. Also f prime w plus fw plus alpha w equals to 0. And if you remember, we chose coefficient of du such a way that we chose alpha such a way that the coefficient of du, which was f prime u by fu plus alpha u, was also 0. Now we will solve these three equations to find the values of fu, fv and fw, and by finding values of fu, fw, we can find what is value of rho, which is number density, because we know rho is equals to n fu, fv, fw. So if we know value of rho, which is again equal to n phi c square, then we can show that how the number density or the number of molecules is dependent on the velocity c, or how the velocities are distributed among the gas molecules.